it is clear that these small giants are much more than minor players in the solar system. From Pluto's complex surface to Eris's bright reflection, to Hahneman's elongated shape and Make's icy surface, each dwarf planet offers a unique insight into history and composition of our cosmic neighborhood. The study of dwarf planets not only enhances our knowledge of our outer solar system, but also inspires curiosity about a broader universe. Hello, welcome back to Aliens Space Education. My name's Andy from spaceforalleducation.com. Just to let you know, I'm sorry for delaying this coming out. There's a lot going on behind the scenes that I'm working really hard to get a lot of things sorted. Spaceforalleducation.com is getting a revamp. The website is under construction behind the scenes. It's just a matter of learning how to incorporate it all so it's better for you guys. So please check the website out as a minute, but as soon as I get it upgraded and changed, I will hopefully you'll all enjoy it. Please like, share, and enjoy these podcasts. Again, the videos will release very soon as I work out how to do the video editing, so you have a more graphical display of what we're talking about. I really hope you enjoy. Today's episode is all about dwarf planets, the smallest giants in our solar system. So, what is a dwarf planet? A dwarf planet starts with exactly what it defines as a dwarf, small planet. According to the International Astronomical Union, a dwarf planet is a celestial body that orbits the Sun, has sufficient mass to assume a nearly round shape, but not enough to clear the orbit of other debris. Okay, it's not a satellite, i.e. a moon. Okay, so what does this mean? This means that it's got to orbit the Sun, and even though it orbits the Sun, it may not be on the same plane as the other planets, i.e. Pluto, which we'll get to. Okay, has sufficient mass to assume a nearly round shape. So it's going to be a ball shape, as close as can be. Some are slightly flatter, some are slightly wider, and all sorts. But not enough to clear its orbit of other debris. So it means that there are other asteroids, such as the Kuiper Belt or the asteroid belt. It's not going to affect them. So they may grab a moon, but it's not going to continuously affect them. It's going to be just that debris. It's not going to draw more in and grow bigger, or it's not going to break apart and go smaller. It's going to stay exactly where it is, and it's going to stay the same. Okay? And it's not a satellite, so it's not a moon. Okay, so it's not orbiting another planet. It's not orbiting the Sun. It's not orbiting. It is a single object out there that's orbiting the Sun or Sol. Okay, the key differences between planet and dwarf planet is that while both orbit the Sun and have sufficient mass to form a nearly round shape, a dwarf planet have not cleared their orbit path of other debris. This makes it distinct from the other 8 planets, which have cleared their orbits. And I'll get to each one individually, so don't worry. Dwarf planets are fascinating because they are often reside in the outer reaches of the solar system, in regions like the Kuiper Belt and the scattered disk. They provide valuable clues about the early solar system and the formation of planetary bodies. So by watching these, we can see how planets are made because they're so small. And they could be the early remnants of bigger masses. And learning about what's included, if they heat up, will they explode? Will they become asteroids? Or if they cool down, will they draw in more gases and things like that by the gravity of the things cooling and pulling things in closer? It's a question we don't know, and that's why dwarf planets are so fascinating. So let's start off with the most famous one. Which one would that be? Pluto, of course. So perhaps the most famous dwarf planet is Pluto, discovered in 1930 by Clyde Tombaugh. I apologize if I said that wrong. Pluto was initially classified as the 9th planet in the solar system, and it was for many, many years until 2006, which is when the IAU, the International Astronomical Union, reclassified it as a dwarf planet due to its inability to clear orbit of other debris, which means it, even though it's in the Kuiper belt, sometimes it's closer than Neptune. It has an unusual orbit. Pluto is located in the Kuiper belt, a region of the solar system beyond Neptune, filled with icy bodies. Its diameter is around 2,300 kilometers and is roughly 1,400 miles. Makes it about a size of about 1/6 of the Earth's moon, so a sixth the size. So cut the moon into 6 pieces, it's one of those. One of the most interesting features about Pluto is its complex surface. The New Horizons spacecraft, which flew past Pluto in 2015, revealed a diverse landscape, including the Tormach Regio, named after the man who discovered it, obviously, a large heart-shaped region composed of nitrogen ice. This area is relatively young and smooth, suggesting recent geological activity. So even out there, that far away, we're still having things like earthquakes or geological activity. We have a Cthulhu region, a dark region which possible organic compounds providing clues about chemical composition on the Pluto's surface, and Charon, Pluto's largest moon, which is about half the size of Pluto itself. Charon is a similar surface, including small canyons or large canyons as well, and significant dark regions called Mordor Macula. Now, Mordor, as some of you may realize, Lord of the Rings. So all these different things all combine to make things differently, and we do pinch names from different things. Pluto's atmosphere is thin and comprised most primarily of nitrogen, with trace amounts of methane and carbon monoxide. Okay, the atmosphere expands and contracts as Pluto moves closer and further from the Sun in its highly elliptical orbit. So it's not doing a circular orbit like most planets, it's doing an elliptical, very egg-shaped orbit. Despite its reclassification, Pluto remains a source of fascination and continues to be a key subject to study of planetary sciences. Its complex geology and dynamic atmosphere provides valuable insight into the outer solar system. So by studying it, we're studying the further reaches, the Kuiper belt, and Pluto is key to that because it's the largest object in the Kuiper belt. What also makes Pluto interesting is Charon is they orbit each other. So it's not clearing debris, they orbit each other and doing an elliptical orbit around the Sun. So sometimes they're closer to Neptune and then they go back out and go further away, come back closer again, but they're still staying together. And Pluto has 5 moons, remember, so it's really diverse. Okay, the next one, Eris, a distant giant. Our next on the list is Eris, a dwarf planet located in the scattered disk in the distant region of the solar system, discovered in 2005 by an astronomer Mike Brown, Chad Trujilli, and David Rabinowski. Eris was the catalyst for the redefinition that was constituted as a planet, leading to Pluto's reclassification. So if we hadn't discovered Eris, Pluto would still be the 9th planet. Eris changed everything because it's the way it orbits the Sun and the size. One notable feature is its highly reflective surface, which is believed to be covered in a layer of ice methane. The surface reflects about 96% of the sun's sunlight that hits it, making Eris one of the brightest objects in the solar system. So if you have a telescope that can see that far, you can see Pluto. Eris will be dynamically bright because 96% of that light is reflected back at you, so it'd be a shining star. That'd be Eris. Eris has a moon named Diocyon, which was shortly discovered after Eris. So we discovered Eris, and then we watched it, and we saw that there's a little light dim, which meant there was a moon. Dyson is roughly 1/5 the size of Eris, orbits one every 16 days. So one orbit is 16 days. The interaction between Eris and Dyson has provided scientists with valuable information about Eris's mass and density. So by knowing how the moon orbits helps us tell more about the planet. That's how we know about our planet. The orbit of Eris is highly elliptical, taking around 561 years to complete one orbit around the Sun. Its distance from the Sun ranges from 38 AU to 96 AU, astronomical units, remember, placing it far beyond Pluto and into the outer reaches of the solar system. Extreme distance makes it a challenging target to study, but its bright surface and interesting moon continues to intrigue astronomers. Now, why would that be? Why would something so bright intrigue us? Well, what reflects light that brightly, that far away that we can see it with a telescope? 38 to 96 astronomical units. So it's 38 times the distance from the Earth to the Sun, yet it's so bright we can see it. And how does it hold on to this ice? It's got to be a gravity ball, so a gravity object, so it's going to be a planet, a dwarf planet, or a really large asteroid. But to hold it and then hold a moon as well, that's a powerful object in space. And at the furthest reaches as well, just beyond the Kuiper Belt. That's interesting. No wonder we're interested. I'm interested. I'm looking forward to learning more. Next, we have Hanuman, the elongated dwarf planet. Now, like I said, most dwarf planets are ball-shaped, circular, but this one's slightly elongated. This one is also located in the Kuiper Belt, discovered in 2004 by a team led by Mike Brown. Hanuman is unique due to its elongated shape, which is a result of rapid rotation. If you have something that you can spin really, really fast, it flattens out. This is what's happened to Hanuman because it is spinning super fast. It's a diameter of about 1,632 kilometers along its axis, but its equatorial diameter is 1,096 kilometers. This elongated shape is due to its fast rotation period of just under 4 hours to do one day is 4 hours, which causes it to flatten at the poles and stretch at the equator. So very similar to Earth. We're slightly wider at the equator and slightly smaller pole to pole. Hanuman is an extreme example of how the rotation affects the shape of a planet. One of the most fascinating aspects of Hanuman is its ring system. Hanuman has a thin, faint ring which was discovered in 2017. The ring is composed of ice particles and is located close to the planet, providing valuable information about the formation and evolution of Hanuman's ring system. So it's spinning super fast and it's created a very thin ring system. Now this could be debris from Hanuman getting thrown off and creating this ring system from the surface, or it could be something else that's broken up close to it, and because it's been so fast, it's stuck and it's spread out so thin. We're not sure. Hanuman also has two of its known moons, Hyakka and Namek. Hyakka is the largest of the two moons, diameter about 310 kilometers, while Namek is smaller, with a diameter of about 170 kilometers. The moons are thought to be composed of similar materials to Hanuman and provide additional context to understanding dwarf planets' composition and formation. So these moons, because they're so close and so small, they could have broken off from Hanuman and been stuck and caught because it's been so fast it's keeping them in orbit, or something could have hit Hanuman and these could be broken off, or they could be just parts of rock that haven't actually made it to Hanuman and the spin is pushing them, keeping them at a distance so they don't crash into Hanuman. We don't fully know. There are different theories about it, but those are the most popular ones. So by understanding these, we understand, the outer reaches of the solar system, but also, what makes a planet, what makes a moon, how a moon's formed. Are they objects caught by the gravity of Humler, or are they parts of Humler that have been thrown off? It's a 50-50 split, but by studying them, we understand more. Humler's surface is covered in a mixture of ice, water, and rock. It has been observed to have a relatively smooth surface with some regions of rugged terrain. The planet's rigid, rapid rotation and unique shape make it a fascinating subject of study in the Kuiper Belt. How many objects do we know spin at 4 hours? 1 day is 4 hours long. It spins that fast. Of course we want to study it. We need to know why it's spinning that fast. Why it has thin rings and 2 moons. That's really intriguing. Next is one of the other ones. Make, an icy resident. Make is the 4th officially recognised dwarf planet and is located in the Kuiper Belt again. Discovered in 2005, again by the team led by Mike Brown. Make is slightly smaller than Pluto, with a diameter of about 1,434 kilometres, or roughly 890 miles. So, not much smaller. Make's surface is covered in a layer of methane ice, which gives it a reddish-brown colour. The exact composition of Make's surface is still under study, but is thought to be similar to that of other objects in the Kuiper Belt, with a mixture of ice and rock. So we think it's very similar, but because we can't see it clearly through a telescope, we haven't got one powerful enough to see that far. But from what we can see, we know it's reddish-brown. Therefore, we know what gas. We know that those ices are reflective, changes colour. Therefore, we can get that. But what's underneath the ice, or is there parts that we can't see, could make it ice and rock? That's why we still have to study these things. One of the most intriguing aspects of Make is that it's a relatively smooth surface with a few visible craters compared to Pluto and Eris. This suggests Make's surface has undergone less geological activity, or that it has experienced some resurfacing process. So it hasn't been as geological activity. So whatever's happened geologically inside it hasn't changed it. So it's relatively smooth. So it's going to be covered mostly with ice. But we have discovered craters, which means those craters could be rock formed or created in rock or in ice. So we know they're craters, which means it's been impacted by something, but it hasn't resurfaced over them. Why? That's the question. That's what we need to study. Make has one known moon, and I apologise for knowing this. It's S/2005 134671. Don't ask me. That's the name of it. It was discovered in 2015. The moon is much smaller than Make and provides additional context of study for the dwarf planet's size and its orbit. Now remember, it's about the size of Pluto, just like the small size of Pluto, so it's likely to have a moon. We have now discovered that moon. The name of it, they number everything, it's easier. But if it's small and smooth surface, that moon must be highly likely an object caught close to it and turned into the moon, not that it broke away or was formed when Make was formed. That's most likely the explanation, but we don't know. There's things we don't understand. Remember, this object's been around billions of years and we've only just discovered it. Like other Kuiper Belt objects, Make is an elliptical orbit. It takes it from about 39 AU to 50 AU from the Sun. Its distance and composition makes it an important object of study to understand the outer region of the solar system. Now, we keep going saying why are these objects so important to study? The fact that they're elliptical means they're further away, which means they're going to pull stuff from the outer solar system in closer so we can see the other objects closer. Think of a comet. It has a tail, it's going to have the trail of ice, rock and ice behind it, but that ice has got to come from somewhere. So these planets of bringing the outer solar system closer to us so we can study them. That's why they're important. The elliptical orbits make them more interesting, but they're much slower than a comet. The role of dwarf planets in understanding the solar system. Dwarf planets play a crucial role in understanding the solar system. They provide valuable insight into the formation and evolution of planetary bodies in the outer regions of the solar system. By studying these objects, scientists can learn more about the early solar system and the process that shaped the planets and their satellites. So it's not just the fact that they're studying that, but how planets are formed. Because these are so small, could these be the origins of bigger planets in the future? The study of dwarf planets also helps us understand diversity objects in the Kuiper Belt and beyond. These small giants offer clues about the conditions and materials present in the early solar system and how they've changed over time. One thing that we've got to take into account is as things get closer to the sun, they heat up. And as many of you know, if you heat an object, it changes. It can melt, it can become more malleable, it can turn into liquid, or it can just evaporate and turn into a gas. These are things that have happened. So early solar system, we had small rocks like this. What changed to make gas giants? What changed to make rocky planets? By studying these objects, it helps us understand these things. Future missions and observations will continue to provide valuable data about dwarf planets, helping us refine our understanding of their composition, structure, and dynamics. As we explore these distant worlds, we gain deeper appreciation to the complexity and diversity of our solar system. Our solar system isn't just Earth and the Moon and our 8 main planets and the Sun. There is so much more we need to learn, and we are going to keep learning. As we conclude our journey through the world of dwarf planets, it is clear that these small giants are much more than minor players in the solar system. From Pluto's complex surface to Eris's bright reflection, to Halley's elongated shape and Make's icy surface, each dwarf planet offers a unique insight into history and composition of our cosmic neighborhood. The study of dwarf planets not only enhances our knowledge of our outer solar system, but also inspires curiosity about a broader universe. As we look forward to future discoveries and missions, these distant worlds will continue to captivate and challenge our understanding of the cosmos and our local neighborhood. Thank you for joining me on this fantastic episode of Aliens Space Education. We will be looking next at, look at this, comets, asteroids and moons. I have it written up here, so I'll be as we dive deeper into comets, asteroids and moons. I look forward to hearing your comments, and please keep listening. Thank you, and don't forget to watch out for the stars. Keep looking up. Thank you.